Hello, my name is Patrick Crampton-Thomas from IndX, and welcome again to our expert series on SAP Digital Manufacturing. So in this session, Clara is going to take us through the line monitoring and analytics capabilities of SAP Digital Manufacturing. So what we're able to do with DM is actually monitor very closely in real time everything that's happening on the line. We're getting a constant feed of information from the production line, from sensors, from the equipment, etc. And we're able to create our own very customizable dashboards and analytics to monitor the production. So we can create reports for things like OEE, analytics, throughput, quality, etc., as well as real-time reports on exceptions, alerts that might pop up, things going out of tolerance and so on, warnings that we need to respond to. So with that, I'm going to hand over to Clara, and she's going to take us through the line monitoring and analytics capabilities of SAP Digital Manufacturing. Thanks.
I am Clara Mas Garcia, and I work as an MES functional consultant at IndX. In the last episode, you went through the last operation of the routine that was packing with my colleague Javier. And in today's episode, we will cover line monitor pod, last indicator value plugin, and also we will explain embedded analytics. Okay, so these are the topics that I already discussed that we were going to cover during this episode: line monitor pod, last indicator value plugin, and embedded analytics. That we built a non-conformance report for the demo. Okay, so this diagram shows how SAP S/4HANA Digital Manufacturing and the shop floor machines connect across ERP, MES, and OT, and on automation layers to deliver real-time data such as last indicator values to the line monitor pod. If you want, you can pause the video and take a look deeper. Okay, so I want to first make a short introduction about line monitor pod. So imagine you're running a production line and you want one single screen that tells you everything that's happening on that line in real time without needing to jump through different systems. So this is exactly what line monitor pod does. So when you open line monitor pod, you immediately see what is being produced right now, how far you are from the target, if any machine or stations are slowing down, quality issues happening at this moment, and some bottlenecks or stops on the line. So it shows live performance, so your team can take action before small issues become big problems. Like, for example, some small stops go unnoticed and delay the production. So with the line monitor pod, as it provides real-time machine status, it enables immediate reaction and prevents extended downtime. Okay, also you need to consider that some configuration needs to take place to be able to get the data that I will show you in a moment directly on DM. Like, for example, create shifts, assign those shifts to the different resources, configure the standard rates for every operation and material. Okay, so now let's go directly to DM, and I will show you there. Okay, so this is the line monitor pod. You can select here the time range and also the work center. So you can see 4 different tabs, and we can switch through them. And also this small square gives like a general overview about each tab. So now let's go through the production tab. So what we can see here, so this tab shows how the line is performing right now in terms of output, and it tells how many units have been produced for a specific order and how the actual production compass to the target. So now let's select one order so you can see better. So for example, for this one, we can see that the planned production was 10 pieces, but the actual production was 9 pieces. So now if we switch now to the quality tab, here we can see, so on this tab, we are able to spot the trends and understand why the quality is improving or if in any area on the line needs some attention. So for this specific order, we can see that 1 piece was scrapped and 9 pieces were produced. Now, if we switch to the Assets tab, here we can see the availability of each resource that are part of this work center. So we have 3 resources. We have the Cooper Machine 2 that has been unscheduled down for a really long period of time. Then we have the Cooper Machine 1 that we can see here in orange, the scheduled down downtimes, and then in red, the unscheduled down ones. And same for the ASCII. Then we will go through the last indicator value plugin later on. Now let's switch to the final tab, that is the OEE, Overall Equipment Effectiveness. So here we can see the availability. So how often the line is actually running, the performance, how fast is running compared to the ideal speed that is configured in the managed standard rates inside DM, and the quality, how many good units are being produced instead of how planned units have to be produced. So if you wanted to check the calculations, there's a small resume in the slide that I presented some minutes ago. Then also we have here 3 different plugins that are related to the losses. So we have availability losses, performance losses, and quality losses. So for this one, you might see some untagged or uncategorized performance losses and quality losses, but that's not an error. So it's just a system waiting for you to assign the category if you want a deeper analysis. Untagged losses simply mean that the system detected performance or quality impact before a recent code was fully assigned. So this is normal during the setup. So that's why we can see some that have a recent code, because these losses had already been configured, and some others that don't have. So for the ones that are still not categorized, we have this plugin that shows the untagged losses. Okay, so this was the last slide that I showed you. Now let's go through the last indicator value plugin. Okay, so the last indicator value plugin is a simple but powerful tool that shows live data from your production machines or processes. It gives the operator an immediate access to the latest, most accurate production indicators, so they always understand current performance without needing to search for information. With this clarity, the operators can react faster on the shop floor, adjusting processes, resolving issues, and keeping the line running smoothly. It gives the customer a single, reliable view of their most important performance data, so they always know exactly what's happening on the shop floor in real time. So how this works? Digital manufacturing is waiting to receive live data from the machine. So, for example, in this case, the current temperature or the torque. And Node-RED acts like a machine simulator that is updating all these stacks. So now let's go through DM and see. Okay, now let's go through the Asset tab. Okay, and we can see here. So we can see that at the moment we have 24 degrees and 51 newtons. So now let's go directly to Node-RED and update the values. So maybe 23 and 56, okay. So now let's go here and it's automatically updated. Okay, so now let's go through the last topic of today's episode. That would be the embedded analytics. So digital manufacturing is continuously capturing all real-time shop floor activity machine events, operator actions, production progress, and all quality results. And it stores all these fast-changing information as health data in the work in progress database. Because this raw execution data is complex to use directly for reporting, digital manufacturing organizes it into manufacturing data objects, which transform the detailed operational data into clean, meaningful business objects such as cycle times, yields, performance indicators, and resource utilizations. These manufacturing data objects simplify analytics by providing a standardized structural layer that is ready for reporting without heavy IT effort or complex data. Some customers frequently use this application for order execution insights, scrap and rework analysis, non-conformance trends, machine downtime, or OEE. So I will show you a small example that we built based on this use case about non-conformance codes. So now let's switch directly into DM. Okay, so in the Manage Dashboard application is where you can find all the reports that you built. So for example, this non-conformance code report that is the one that we built. So this might take some seconds. Okay, so first what I want to introduce is that the filtering. So for example, we created a specific report for your use case. So we filter the data. Also, we filter by material. That this is the one that we've been aiming to produce during all these episodes. Also, we filter by the non-conformance codes that we wanted to see, that were only the couple ones. All the resources that took place, and the plan that is the plan that we are working on. So all these filters can be configured and can be established, so there's no update on those. Okay, now for example, you can see different graphs and parameters that have been populated to be shown in this report. So here you can see the quantity per resource. So all the non-conformance code that have been raised within the different resources, all the non-conformance by material, that it's the only material that we filtered, as you could see. Then I don't know if the camera noticed that, but the report is refreshing every 30 seconds. This is also some parameter that is configurable. Then we can see here the quantity per non-conformance code, how many non-conformance code were raised. I mean, how many times which non-conformance code was raised, and the percentage of the total quantity. Then in the second page, we can see two different tables. So this is so these two tables were mandatory, so to be able to prepare all the data that you saw in the other page. So what we're doing is taking all this data to be able to produce all these different charts. Thank you so much for watching. So that was the end of this episode. Don't forget to see the next one that will cover Rio, and also will close this expert series.